Hello guys, welcome back to my channel, Taking Boy. It's another Simulkuy episode, and we are still on the series of process simulation utilities. Today I would like to discuss one of the utilities called boiling point curve utilities. This is one of the utilities that widely used if we want to simulate refinery processes or midstream and downstream processes in oil and gas. Okay, so if you would like to know further about these utilities, make sure you watch this video up to the end, and let's go to simulate. Okay guys, so this is my simulation file, and I have prepared the basis environment. First, from the fluid package, I choose Pang Robinson, then I use Oil Manager. So I have prepared the assays. Yeah, this is actually an arbitrary value, so I just do random number here, but it should be make sense. Yeah, so the say percent will be 0 to 100, while the temperature will always going up. The block properties, I use the option of not use, so I purely calculate the assay from the ASTM D86. If you haven't familiar with Oil Manager, please do watch one of my old video that discuss about Oil Manager and come back here again. Okay, so after I calculate, then put it inside a blend, then I install the oil. So I have one stream now, which is the test stream, and this stream already contain the composition of the Oil Manager. Okay, so this is a composition. I will fully define this stream. Yeah, let's put 1 atmosphere for the pressure, any value for the flow, because actually for boiling point, it's not really matter. For temperature, I want to make it like in the middle of vapor and also liquid. Yeah, so I will check at which temperature it will start to become vapor. It's 154, so I will take 180. Okay, so this stream will have around 30% of vapor. Okay, next I want to use separator, which have two outlet pipe and also the liquid. Okay, so what is the function of boiling point curve utilities? First, in this case, we input the test stream only in one basis. Yeah, we see, we go back to this Oil Manager and then see the assays. Yeah, we use the ASTM D86, and this is the input. So how if we use other standard like D1160, D2887, the input will be different, but we don't know what will be the input. Another thing is we don't really put the same percent in the standardized way, so it's just a random one. But the simulator have the features or the utilities to calculate the boiling point curve in appropriate way. That's the first thing. The second thing about the product, which is the vapor and also the liquid. Currently, the composition of the vapor and the liquid is part of the feed. Yeah, it's the hypothetical component of the feed, but we don't really know about the boiling point curve of the product. This is not the boiling point curve of the product. This is only the composition of the vapor in terms of the hypothetical components that is created by the feed basis. Okay, that's the same thing with the liquid. The liquid composition is presented as a hypothetical components based on the feed data. So it's not based on the liquid product. So if we want to know the boiling point curve of our product, we could also use this utility. Okay, now to add the utility, we can press the Control U. So the boiling point curve is in the first point. I will click Add Utility. I will give name stream boiling point curve. Okay, so there are several type of objects like stream, section, separator, condenser, and deboiler, but it's actually could be classified by two groups, which is the stream and also the equipment. So first, I want to focus on the stream object. Yeah. In the same object, we can specify which stream that we want to analyze. So in this case, I will put all of the stream. Okay, we will put the multiple stream as the first option. We will see how it will calculate. So here, if you see from the performance, this is the first result, which is the boiling point curve. So this boiling point curve could be used as an input to the oil manager. So you can use this result, copy to the oil manager, and it is presented in several methodology, such as true boiling point, ASM D86, and others. From this feature, we could see and compare every methods. Yeah, how is the result? Which one is similar? Which one is different from each other? If we want to check another string, we just need to click the drop down here and change to other string. Another one is about the critical properties. So it is contain critical temperature, pressure, eccentric factor, the molecular weight, and liquid density. And all of these parameters are presented for each cut point. Yeah, for each cut point have their own critical properties. The next one is about the cold properties. So this is very interesting, and I think that it will be widely used in oil and gas simulation. So we could evaluate the vapor pressure or the rate vapor pressure or RVP. This one is very common to measure or to evaluate the quality of products. Another thing is about the fresh point and the pour point. This is also quite common to measure or to evaluate the quality of product. The refractive index, Cetan index, research octane number, viscosity. Yeah. So this is called as the cold properties. And they also have the PNA analysis. So our feed is consisted of how much percent of paraffin, how much percent of naphthens, and how much percent of aromatics. The next one is about the plot. So we can plot the boiling point curve for each of the stream. You could see here, this is the leak curve, the test curve, and also the vapor curve. Then we also could change the method. Yeah. Using ASTM D86, using D1160. Yeah. So it will result in a different graph. And of course, you can copy this graph to other application. We are also able to see the critical temperature, pressure, eccentric factor, and other stuff. We also could see other parameters, which is the critical temperature and pressure, eccentric factor, molecular weight, and liquid density. Yeah, so we could see all of these parameters in the plot format. So now, how about the option of composite stream? So for composite stream, they will create a new stream, which is called the composite stream. And this composite stream is like the merge between all of the stream that we put at this page. Okay, so we could see from the plot that the composite stream will range from 0 to 100% of the volume percent. But for our test liquid and also vapor, it is not from 0 to 100. It will be separated. Yeah. So in this case, the test liquid density will be 0 to 50% volume percent. Then the liquid one will be from 50% to around 88%. Then lastly, the vapor is from 88% to 100%. So it will be divided the input streams into several regions. And this is the resultant. Yeah. So the composite curve will be the resultant of these three streams. Okay, so beside analyzing the stream, we also can analyze the equipment. So if we add another one, and I will give name a vessel boiling point curve, we could change the stream into separated. Yeah, because I use separator here, then we can select the object. Yeah. So what does this BP curve calculate it if we choose the separator? It will calculate the liquid and also the vapor product. Okay, so this is the result for vapor phase. And we change here to liquid and it will be the result of the liquid phase. Now we can compare with the previous one, vapor phase. Okay, so it's the same. And for liquid phase, yeah, so it's the same. So it's not a way for you to analyze the streams, but it is based on the equipment. So in this case of separator, we want to know what is the product boiling point curve, yeah, for both liquid and also the vapor. Okay guys, so I hope you get more understanding in utilities, especially on boiling point curve. And see you in the next episode of Simulkuy. And stay tuned for this process simulation utility series. Bye bye.